speak English, but my presentation is on Serbian. In nowadays, we have powerful software tools like and meteorology basis data, and we can ask very old question. What is the best orientation of the building from view of energy efficiency and consumption of energy for their heating or cooling? Having in mind environment and thermal comfort conditions inside. In this geography area, we have winter and summer season of usage of buildings, which dictate needs for heating or cooling. And we can check usual opinion that southward orientation is the best, because it can get the best of solar radiation. In history is Socrates, Greek philosophy from 4th century before Christ. He considered that houses should has a southward orientation. But this analyze shows that opinion we have little check. Optimal orientation of objects depends on many factors, which has impact of thermal behavior. These factors are different by azimuth, and they are roughly can divide in meteorology factors, astronomical factors, and geography factors. In meteorology factors, we have outside temperature, solar radiation, and direction and speed of wind. In astronomy factors, we have sunrise and sunset and movement of the sun across the sky. And geography factors, we have configuration of the ground, which have impact of line of horizon, and geography coordinates. I use Microsoft Excel for calculation, and this is very worldwide known program. Also, I use meteorological data of Meteonor and his basis of typical meteorological year. In this paper, like example, I use typical meteorology year for Belgrade from program Meteonor. Astronomical calculation could be used from well-known literature from solar energetics, and geography input data could be precisely get from geodetic observing of line of horizons, but we can also use and plans with levels of ground and isohypsis. From well-known literature, I use the formula for calculating parameters on our level, like hour angle, altitude of the sun, and azimuth of the sun. And this is movement of the sun was calculated for whole year in Microsoft Excel program in 8,760 rows. And this is parameters depends of geographic coordinates and declination angle and movement Earth around the sun. This is very important data because we can consider solar radiation by angles. Also, we can calculate it, solar radiation, how can lie to surfaces which is not horizontal. With geography input data, we have geography longitude and latitude and ground configuration. For precisely defining line of horizon, we can use geodetic observing. I use meteonorm, typical meteorological year for Belgrade, and in Excel we can convenient radar diagram which can easily present thermal heating and cooling needs for houses. And that next slides I will show how is this consumption of heating is for Belgrade in degree hour, and it is a deeply analysis than we use today, which is based on average daily data. Here is picture is very interesting because we can see that here is a 24-hour per day, and in every direction we have consumption of heating for location. And we know that early in the morning is the lowest temperature during the day, and in the midday we have a higher temperature, and we can notice that we need much more energy in the morning, like this, in about 5 o'clock in the morning, and during 15 or 16 hours, we need almost double less energy. On next slide. We have thermal loads for cooling, and these loads, is if we consider hours which is in database are higher than 26 degrees. And we have noticed that we have loads for cooling only in the afternoon in Belgrade. So it's important and shows that is the best orientation for cooling is something like northeast. All this data are considered and based for calculation for whole year. So first picture shows that is the best orientation if we consider that solar energy we can use only when we need consumption. That is the eastern and southeastern orientation is the best. And that's why I think the southward orientation is not the optimal for Belgrade. Also, I, in this paper, consider U value of envelope, and I use worse isolation, better isolation, and almost passive houses. And this is U value is like 1 or 0.5, 0.2. And on next figure, I can show solar radiation and consumption needs for heating, and we can notice that bigger portion of this is for if worst isolation, and bigger portion if solar energy can cover, and that means that we can use solar energy for heating. And in this way, if it's worse solution, we can use southward orientation, but if we have better isolation, picture is little different, and we have in this part is if red line is eastern wall, green line is southern wall, I don't see what kind of light. I have southeastward. This part is a portion of energy we can use in the morning and get preheating. And if we have southern wall, only this part is, which is much less than this part, used for heating. So that is my conclusion, that we can, it's better use eastern orientation than a south orientation. And also we have almost passive houses, whereas this area is more, we can get conclusion that for passive houses better eastern isolation than southward isolation orientation. Also, I didn't consider of mass, but I consider only that we can use solar energy, and the best way of using solar energy is if we use solar energy when we have, that's way how we need solar energy. About organization of data in Excel table, this data divides in column like geography data, astronomy data, and meteorology data. And also I have meteorology data by hour per day, and also I have attitude of the wall. And for conclusion, I consider influence of geography and astronomical and meteorological data for optimal orientation. I didn't present formulas, but I use Microsoft Excel table and radar diagram for this presentation. And meteorological data is from MetaNorm program, which I have apply typical meteorological year for Belgrade. And for conclusion from radar diagram, we can consider that for Belgrade is better isolation for well isolated houses, and passive houses is better southeastern or eastern orientation because we need for heating and cooling. And for cooling is better is northeast orientation. And I consider that compromise of that consumption for heating and cooling is east orientation, and that is much better than south orientation. Thank you very much.